Dear learners, my name is Dr. Rajeev Kumar Mishra and I am working as an associate professor in one of the IITs affiliated colleges. And my research area is renewable energy in general and solar energy in particular. So, in this lecture, I am going to discuss with you about greenhouse dryers. In previous lectures, we have discussed different types of dryers and why these dryers are required, why drying is basically required. And to make you understand this topic, I have prepared a presentation which has been divided into the following contents. First, I'll give you the brief introduction about the different types of dryers and why drying is required basically. Then solar drying. Then we'll discuss briefly about the various solar drying processes, solar drying techniques. Then we'll try to classify the different types of solar dryers. And greenhouse dryer is one of that solar dryer which we discuss in detail in this lecture. Then working principle of greenhouse dryer, principle called as the greenhouse effect. And this greenhouse effect is the principle behind the greenhouse dryers. Then we'll discuss the classification of solar greenhouse dryers and advantages and disadvantages of the solar greenhouse dryers. So these are the contents, and on the basis of these contents we'll try to discuss about the greenhouse dryers. So we all know that food is a basic need of a human being after air and water for survival of their life. Food holds a key position in the development of any nation. The preservation of food for its oxygen availability has been in practice since the dawn of civilization, and it is not a new practice. One of the oldest methods of food preservation is the drying and storage, because if you want to store your food for longer duration, then it must have some limited quantity of the moisture content, and if the moisture is very high, then there is a spoilage of the food occurs. For that, drying is required. These things we have already discussed in previous lectures. So drying of a product is basically referred to as the removal of moisture from the product. Drying helps in reducing the moisture content of a product to a level below which deterioration does not occur, and we can store our food for a different period of time. Yes, it is okay that that period will be defined by the different types of crops, that different period may be different for the different food products. So different food products have different level of safe moisture content at which the food product can be safely stored for a longer duration. And this is a schematic diagram, a block diagram. On the basis of that, we can understand what we actually do in the drying process. A wet product will be there. Wet product means that dry product contained with the moisture, and we blow some hot air inside that wet product. And what does the hot air do? That hot air extract the heat content of that product, and we end with the dry product, and the humidity or the moisture removed from that wet product, and we get the dry product. And this dry product, which have some basic level of moisture, can be stored for a longer duration. Drying rates, that is how the fast or slow the drying of agriculture products depends on few external and internal parameters. The external parameters may be dry bulb temperature, and dry bulb temperature is basically the actual air temperature measured by using a common thermometer bulb or thermocouple. And relative humidity. Relative humidity is one of the very important parameter. If you want to discuss this drying process, then relative humidity is one of the very basic parameter, which is defined as the ratio of water vapor to the saturation vapor pressure at same temperature, and is normally expressed in percentage. And the air velocity. Air velocity is also play a very important role in the drying of any food or crop. Surface heat transfer coefficient is also very important external parameter, which is a measure of overall heat transfer ability of a series of conductive and convective barriers. We have already discussed these things, that drying is not a simple process. It's a complex phenomena. It's a complex process. Large number of convective, conductive heat transfer phenomena takes place in the drying process. And some internal parameters are there, like surface to volume ratio, which is the amount of the surface area per unit volume to an object. Surface temperature is the temperature at or near the surface. Specifically, it may refer to surface air temperature, the temperature of the air near to the surface of the earth basically, and the rate of the moisture loss. Okay, how fast or how slow the moisture is extracting from your food, from your wet product. Then composition, that is the moisture and fat. In wet product, what are the fractions of dry product and moisture? If moisture will be more, then your product will take more time to dry. And various drying techniques have been developed in order to preserve the agriculture food product or crops. Solar drying has proven to be one of the very important and widely used drying technology. We have already discussed how this solar drying is becoming one of the very important drying technology. Then application of solar energy in food processing industry is mainly limited to drying operations. Application of the solar energy, a lot of applications are also there, but in food industry, the solar energy has limited application in the drying industries. Solar vegetables, fruit dryers operating below 55 degrees Celsius are used for the purposes. In recent years, many solar gadgets have been developed for a variety of applications. Because of excellent consistent quality, material processed in these units or gadgets can enjoy great market potential. Extremely low capital investment in this solar drying technology make it financially possible. The process of solar drying differs from the above mentioned other techniques by the way of heating of air by using the solar radiation. And you know the solar radiation is abundantly available to us, which is free of cost. You don't need to pay any amount for using this solar energy. But the only thing is that you have to use some proper technology by which you can utilize it. The heated air could be circulated naturally or by a ventilator powered by PV array or electricity. And drying is basically involves two phenomena: heat transfer and mass transfer. And we have seen that drying is a complicated process which involves various heat and mass transfer concepts. And we have discussed that in solar drying basically, the solar energy used to heat up the air. Solar dryers are predominantly used in agriculture industry to dry foods and storage purposes. There are direct and indirect type solar dryers, and some mixed dryers are also there. We'll discuss it in the maybe in the further lecture or in this lecture also. We have understand these two types of solar drying with the help of these two diagrams. The first one is the direct solar dryer, and second one is the indirect solar dryer. In direct solar dryer, we can see this with the help of this diagram. We try to understand it. The direct drying system expose the product to the direct sunlight. The key processes here are heat transfer from the heating source. You can see here some crop is there inside this direct solar dryer, and that is heated by the source, which is sun. Solar energy is falling through this glass cover to the crop, and in these systems the drying process is sometimes assisted by airflow, which helps the transport moisture convectively. The convection will take place, and this moisture will taken away by the air which is flowing from the bottom. And you know that the hot air has a tendency to rise up in up direction, and hence the moisture content of this crop will go from the in the form of hot air from the top. And in another one, which is the indirect type solar dryer. Indirect type solar dryer use absorbing surface which heat the air, which is further passed over the target product. So there is no direct contact of solar radiation with the product in the design. In indirect solar dryer systems, it is easier to protect the agriculture product from external damage. That is, since no direct heating is there, so if you can avoid the overheating of the material. So these are the components of the solar dryers. Basically, solar dryers will have some solar collector, solar air collector, air handling unit, and drying chamber. So solar air collector, also called as the solar air heaters, are used to heat the ambient air, and this ambient air is being used in the air handling unit to dry the product. There are actually several designs of these solar air dryers, solar air heaters rather. The air handling unit consists of blower and suitable duct work. The air handling unit takes heated air from the solar collector and sends it to the drying unit. And we used to keep our crop or food product in the drying chamber. And the drying takes place basically in the drying unit, where the heated air extracts the moisture from the product to be dried. Many designs are available for this drying unit. And here you can see in this sketch, in this diagram, the solar radiation basically falls in the solar collectors, which is being heated, and this hot air is being handled by the air handling unit. The hot air being passed to the drying chamber. Your crop gets dried, wet product will be there which gets dried, and we end up with the humid air out. And we can classify the solar dryers as the drying by using the solar energy can be broadly classified as open sun drying and controlled drying. Open sun drying we have already discussed in detail in the previous lecture, where the product are spread in the open space in thin layer and exposed directly to the sun. We have already discussed this process in details in previous lectures. Though this process is economical but have some disadvantages, like open sun drying requires presence of somebody at the site throughout the drying period, so that the product could be protected from birds, animals and adverse weather conditions. Since your product is drying in open sun, some rain, for example, if rain is there, then someone must be there to save your crop. The resulting dried products are not of very high quality because of ducts and other sediments present in the atmosphere. The products are usually unhygienic, since dust are there where your product is in open space, so it's not as much hygienic. Sun drying tends to be labor intensive also and has limited capacity. Temperature control is also difficult in this method, and the product can easily be overheated, causing cracked grains which lead to the low milling quality. It is also not possible to open sun dry at night or during the rain. Above problems can be resolved by using controlled solar dryers. And here in this classification you can see that controlled solar dryers, we have two types of modes of operation, you can say passive mode and active mode. And in this passive mode and active modes, we have some greenhouse dryers and cabinet dryers. So in this lecture, we are mainly focusing on the greenhouse dryers. So we have seen how these greenhouse dryers are required, why solar dryers are superior as comparison with the open sun drying. So greenhouse dryer we are going to discuss now. Greenhouse dryer is an enclosed structure having transparent walls and roofs made up of glass, polythenes, film, etc. Here, the product need to be dried is placed in the trays receiving the solar radiation through the plastic cover or glass, and the moisture is removed by natural circulation or forced circulation. We'll discuss in the further slide that two modes of operation will be there. One is natural convection and another is forced convection. This technology improves the product quality and reduces the drying period also. Solar greenhouse dryers are characterized by having extensive glazing on their south facing side. You know that throughout the year, if you measure the solar radiation, the maximum solar radiation we found on the south facing sides, while the other sides are well insulated. Insulation is required so that once the sun radiation which is falling on the roof of the greenhouse dryer enters in the dryer, it is contracted inside your greenhouse. Some means are provided to store the daytime excess heat. Vents are strategically sized and positioned to control the airflow. A well-designed greenhouse dryer permits a greater degree of control over the drying process than the solar cabinet dryers. Solar cabinet dryers we'll discuss in the maybe in the next lecture, and should be used where relatively large quantity of products will be dried. If you go for the industrial drying, for example, where the large amount of products need to be dried, then we prefer this greenhouse dryers over any solar dryer like cabinet dryer. Then this solar greenhouse dryer is basically work on the greenhouse effect. So some of you might be aware of this greenhouse effect, that the greenhouse effect is a natural process that warms the earth's surface. When the sun's energy reaches the earth's atmosphere, some of this incoming solar radiation is being reflected back to the space, and rest is absorbed and re-radiated by greenhouse gases. Greenhouse gases includes water vapor, carbon dioxide, methane, nitrous oxide, ozone, and some artificial chemicals such as chlorofluorocarbon. You all know that these are the like ACs and freezes. These are the equipments which emits this chlorofluorocarbon gases, and some of you have heard that the ozone layer is depleting because of these harmful gases. The absorbed energy warms the atmosphere and the surface of the earth. This process maintains the earth's temperature at around 33 degrees Celsius, warmer than it could otherwise be, allowing the life on the earth. So in this diagram, we have just tried to explain the process of how this greenhouse effect occurs. And this greenhouse effect is basically the principle behind the greenhouse dryer. So these are the steps why the greenhouse effect occurs. In step 1, solar radiation reaches the earth atmosphere. Some of this is reflected back into this space. And in step 2, these steps are being shown here in this diagram. In step 2, the rest of the sun's energy is absorbed by the land and the oceans, heating the earth. In step 3, heat radiates from earth towards the space. In step 4, some of this heat is trapped by the greenhouse gases in the atmosphere, keeping the earth warm enough to sustain life here. Step 5, human activities such as burning fossil fuels, agriculture and land clearing are increasing the amount of greenhouse gases. You know that carbon dioxide, especially the carbon dioxide, which is the very harmful and polluting gas, it is increasing the amount of greenhouse gases released into the atmosphere. And in the step 6, it is trapped extra heat and causing the earth atmosphere to rise, the temperature of the earth atmosphere to rise. And on this principle, the greenhouse dryer works, and the crops are generally spread on the tray of dryer where they receive short wavelength solar energy during a major part of the day and also natural air circulation. The solar plate is placed which contain aluminum meshing sheet which collects the heat from the sun. The absorbed radiation is converted into thermal energy and the temperature of the materials starts to increase. The long wave radiation from the surface of the crop to the ambient air through moist air and also convective heat due to the blowing wind through moist air over the crop surface. The moisture is taken away by the air entering into the greenhouse from below and escaping through at the top exit way in the dryer. Of the total solar radiation impinging on the tray cover, a part is reflected back to the atmosphere and remaining is transmitted in the greenhouse. The part of transmitted radiation is then absorbed by the surface of the crop, which causes its temperature to increase and thereby emit long wavelength radiations which are not allowing to escape to atmosphere due to the green poly cover or glass cover. The overall phenomena causes the temperature above the crop inside the dryer to be higher. The greenhouse poly cover in this serves in reducing the direct convective loss to the ambient, which plays an important role in increasing the crop and inside dryer temperature. So these are the classification of the greenhouse dryers. There are some bases on which we try to classify these greenhouse dryers, and first is on the basis of the airflow. There are two types of airflow may be there, natural convection or forced convection. Natural convection is sometimes also called as the passive mode of heating, and the forced convection is called as the active mode of heating. In a passive solar dryer, air is heated and circulated naturally or by buoyancy or as a result of wind pressure in a combination of for both. Here the food crop need to be dried or placed inside the greenhouse. You can see here in this diagram also that your crop is placed inside the greenhouse with canopy cover. The air from the bottom of the greenhouse enters into it. Air gets heated by the solar energy because due to the greenhouse effect, the temperature inside the greenhouse increases. The hot air goes up because of the buoyancy and the moisture content with the crop go out with the air and the crop gets dried. And in second, that is the active or forced convection. Here you can see in active dryer, air is heated and circulated with the help of the fan placed at the top of the greenhouse. Here the food crop need to be dried or placed inside the greenhouse with canopy cover. The air from the bottom will enter into the greenhouse. The air gets heated and it will extract the heat content of your crop. But here we use a fan, maybe operated by the solar energy on the top, and with the help of this fan we just made this greenhouse active. So you can compare these two dryers, passive and active. That is, the advantage of this passive dryer are the same. It is simple to design and low installation and operation cost. But the limitation is the capacity per unit area of dryer is limited. Whereas in force convection solar dryers, that is also known as the active dryers, the higher drying rate compared to the passive dryers. That the rate will be faster here because you are using a fan to extract the heat from the surface of your crop, and higher drying rate compared with to the passive dryers can be used for higher produce. But the limitation is that more complex and expensive than the passive dryers. So on the basis of this advantage and limitations, we can decide that for our applications which dryer will be suitable. And another very important dryer is called as the hybrid photovoltaic thermal PBT integrated greenhouse dryer. Here the fan which is used in the active dryers are being operated by the PV module be installed at the roof of this greenhouse dryer. This can be seen in this diagram also. So we can also classify the solar greenhouse dryer on the basis of the covering material. We can use polythene, we can use polycarbonate sheet covered, we can use glass cover, and on the basis of structure, even span roof type, parabolic shaped. On the basis of floor, you can also classify this solar greenhouse dryers. Like if you use concrete floor, you can use PVC sheet floor, we can use rock bed or stand floor. So the idea of the greenhouse dryer is to replace the function of solar collector by the greenhouse system. The design properly, greenhouse dryer allow a greater degree of control over the drying process than the cabinet dryers, and they are more appropriate for large scale applications. Then we can have natural convection greenhouse dryer. Here in this diagram you can see that it is clear that this dryer consists of two parallel row of drying platforms along the long side of galvanized iron wire mesh surface laid over the wooden beams. A fixed slanted glass roof over the platform allows the solar radiation to fall over the product. You can see here in this diagram the dryer aligned lengthwise in the north-south axis, had black coated internal walls, improved absorption of solar radiation. A ridge cap made of folded zinc sheet over the roof provided an air exit vent. Shutters are also at the outer side of the platform regulated the air inlet. So another type of solar greenhouse dryer is the natural convection greenhouse dryer. The diagram is being shown here. The earliest form of practically realized natural circulation greenhouse dryers reported was the Brace Research Institute glass roof solar dryer. The dryer is shown in this figure. From figure it is clear that this dryer consists of two parallel rows of drying platforms along the long side of galvanized iron wire mesh surface and laid over wooden beams. A fixed slanted glass roof over the platform allowed solar energy to fall over the product. The dryer aligned lengthwise in the north-south axis, had black coated internal walls for improved absorption of solar energy, because you know that the black surface absorbs more solar energy. The ridge cap made of folded zinc sheet over the roof provides an air exit vent. Shutters at the outer sides of the platforms regulated the air inlet. And another type of greenhouse dryer is the natural convection greenhouse dryer with chimney. A simplified design of the typical greenhouse type solar natural circulation solar dryer consists of a transparent semi-cylindrical drying chamber with an attached cylindrical chimney rising vertically out of one end, while the other end is equipped with a door for air inlet and access to the drying chamber. If you want to put your crop in the drying, then you can enter from this side. The chimney has maximum possible height of 3 meter above the chamber and diameter of 1.64 meter. It is the design parameter for this natural convection greenhouse dryer with chimney. The drying chamber was a modified and augmented version of a commercially available polytunnel type greenhouse. The dryer operates by the action of solar energy impinges direct on the crop within the dryer. The crop and the vertically huge black absorbing curtain within the chimney absorbs the solar radiation and it warms the crop. The surrounding air is in turn heated. As this heated air rise and flows up the chimney to the consist of the dryer. Fresh replenishing air is drawn in from the other end of the dryer and your crop gets dried. So these are some of the advantages of this greenhouse dryer. The advantage of the greenhouse dryer, you know that it uses the renewable energy, and greenhouse dryers are the better quality product than the open sun drying. Also, the greenhouse dryer reduces the moisture content in a very less time compared to the open sun drying. It has also advantage that the materials to be dried is protected from the dust and rain. So in this lecture we have discussed the why these greenhouse dryers are much more important in comparison to the open sun drying, and we have discussed different types of solar greenhouse dryers, different modes of greenhouse dryers. We have classified the solar greenhouse dryers on different basis, like whether the cover may be different or modes of operation will be different. So these things we have discussed in this lecture. Thank you very much.